show IP OSPF neighbor, just to kind of see where we're at. And indeed, we have no neighbor adjacencies there. So what we're going to need to first do is look at those interfaces, make sure they're up. So we're going to do a show interface brief. And we do see interface 1 is up, as well as 24, which is those adjacencies or those links to the other routers. So next we want to do is let's concentrate on 8. So the connection to 8. So we're going to do a ping towards it. And we can see that we have success. So we do have IP connectivity to that router. However, for one reason or not, we do not have OSPF adjacencies. So what we're going to do is take a look at that interfaces that we have for OSPF. And indeed, we only see one available or one configured, and that is the one that's actually going out to Ruckus 4. So the one going to 8 is not configured for OSPF, so we're going to need to do that. So let's go in and configure it. And that should do it for us. Let's give it a moment to configure or to discover each other. And we see we have a full adjacency with 8 now. Let's now move on to our adjacency with Ruckus 4 and see what might be the problem there. So we're going to do the same thing. We're going to try to go ahead and ping that interface going out to it. We've already verified the interface is up and functioning. And we are not seeing adjacency, or at least layer 3 connectivity towards 4. Let's go ahead and look at the interface real quick again. And we see we're sending packets or hello packets out. We're just not getting anything back. So we're going to need to look at the other side of this adjacency or this link. So we're going to go over to 4 and take a look. We're going to do a show IP OSPF interface E as well. And let's take a look and see what we see here. We see also that packets are being sent out as well. So therefore, the connection there is, for some reason, we're not getting layer 3 connectivity. And I can see now, if we look at the interface address of that interface, it looks as if that address has actually been transposed in the 3rd octet. So we're going to need to fix that for layer 3 connectivity for OSPF to function. So let's go ahead and do that now. Just to make it safe. And then we're going to add in the correct IP address. I'm going to enable it. Make sure it's up. Do show it back up, and let's see if we can do show IP OSPF interface now. We do see it up, and we're seeing hello packets as well this time. So that is an indication that we're having better luck with that interface. We'll give it a moment to connect. Give it one more try here. And we do show success. We're seeing some database packets being sent and received, hello packets, also LSA acknowledgments. So that's a good sign. So we can do a show IP OSPF now. And we have neighbor adjacency. So we have now corrected the 2 adjacency issues that router 3 had. So now that we've done that, let's go ahead and confirm that we can now ping that the IP address or the loopback address of that neighbor. As we can see, the neighbor there is 10.3.3.3. That's the neighbor ID. So let's go ahead and see if we can ping that. Got to get out of there. And we are seeing that we're having issues connecting to that. Let's see if there's something in the routing table representing it. And we don't see anything in the routing table for that as well. We see the one going to Ruckus 8, and of course we see our own. We see the adjacency, we see the correct adjacencies and routes in there, but we're not seeing anything to that loopback address. So let's go back into 3 and see what might be going on with it. So we're going to go back to 3. We'll see if interfaces are up. So we show the loopback is configured. We can identify that because the router ID was configured for that. So let's go in and look at if it's being redistributed. My fingers can work. And we're not showing that it's being redistributed as a route. So therefore it means that for whatever reason it is not configured. So we're going to do a show run and look at that loopback interface. And we can see at this point it is not enabled for OSPF. So that interface has to either be redistributed, which we did not see any redistributing taking place, as we can see with our OSPF configuration here, nor is it enabled for OSPF for it to be distributed through OSPF. So as a result, we need to go into that loopback interface and enable it for OSPF as well, for it to be advertised out. And in doing so, that should allow it to be in the routing tables. And we can see now that it is being advertised. So we can see that area 0 has that, so the 333. So we should now be able to go back to 4 and see if we can ping that and see if it's in its routing table now. So as a result of adding that interface 0, we can see it's there. So let's go ahead and just do a ping just to make sure. And as a result, we can now ping the loopback interface. So either redistribute or add that interface in for it to be sent through OSPF. One thing to consider is that if you redistribute, then it's going to cause that router 3 to become an ASBR, meaning that that route that it's redistributing that is not native to OSPF is going to be considered a redistribute route and cause it to be an ASBR. So generally it's a better habit to just enable that OSPF into that loopback interface, allow it to be native to OSPF, thus cutting down on the link state database entries that we have, or introducing external routes into OSPF. So the one last task we want to look at here is that if we can ping the internet, and we're going to represent the internet from an IP address of 144.49.210.99. And we see that is not routable. We also see in the routing table up above that it is not in there as well. So we need to go closer to the internet within this environment, which is router 8. We'll take a look and see if it has a pingability to that internet as well as has routes within its routing table. So let's go into router 8, show IP route. So we don't see an explicit route here out to that address, but we do see a default route, which was not represented in router 4. So let's see by using the default route, this device can ping or get a response from that address. So what we have here is this route is actually being sent out the default route. Again, not represented in 4, and so 4 was not reachable or was not able to reach that address. So we can do one of two things. We can either have this default route, which is represented as a static route or configured locally on this device, have this device redistribute or send out that default route, or add that route specifically to 4. But again, that's only one address. We would have to represent many addresses for it to represent the internet. So I think the best choice for us to do is just have this default route repropagated throughout the environment. And we're going to need to do that with a specific command within OSPF. When we look at the config output of this device, we actually see it's got a redistribute static. The default is a static route. However, it is not going to be advertised specifically with this default or this redistribute static. What it is doing with that command is actually redistributing that 192.168, which we did see represented in router 4's routing table, but we did not see this default route. What was required to be able to send that out is the default information originate command that will need to be configured underneath OSPF, and that allows this device to be able to send out that default route specifically or explicitly, allowing other devices that do not have any specific routes within their routing table to be able to send it out, and of course sending it forward towards this router 8. So let's configure that. Default information well, if I can spell correctly, information originate. This is specific to the default routes that are being sent out. So this device, once I push enter here, will now use that route, that default route that it has, and share that with other OSPF neighbors it has in the environment. So once we've done that, let's go back to 4 and look at its routing table now. So we can now see that that route, the default route represented by the first entry there, is now being shared in OSPF. So router 8 is sending that out. So anything that does not have an explicit address will now be routed using this default route. Let's go ahead and ping it now and see if we have success. And we see it is successful. Now devices should be able to, in this environment, be able to reach the internet as well as have adjacency routes from OSPF's perspective to the other routers within the environment. And I think we've solved the issues that need to be